Welcome to this presentation of Introduction to Blockchain Technology, presented by Coding Bootcamps. This is the Introduction to Blockchain Technology, the history of blockchain technology, and Bitcoin. About our instructor, Jim Sullivan is a senior blockchain instructor and developer with DC Webmakers. As a software engineer with 18 years, Jim leads an expert team in blockchain development, including DevOps, cloud application development, and the safe, agile methodology. Jim is an expert in blockchain platforms such as Hyperledger, Ethereum, and Corda. So, a little bit about blockchain. So, most people really heard about blockchain when Bitcoin made its run in 2017. We all remember that the price per Bitcoin made it to about $20,000 per Bitcoin, possibly slightly over that. Some people will be surprised, but Bitcoin and blockchain are not the same thing. We all heard a lot about blockchain when the price of Bitcoin was approaching $20,000. A blockchain can run without a Bitcoin. So a Bitcoin is merely just an application that runs on top of a blockchain. Bitcoin cannot exist without a blockchain because Bitcoin, again, is the application that runs on the blockchain. Blockchain technology exists well beyond Bitcoin or any other cryptocurrency. So we see blockchain technology used for tracking inventory, tracking the medical records. It can even track mortgage. We hear some products out there that will secure your mortgage. Well, a blockchain can also secure your mortgage or any other types of paperwork. Notary, anything like that can be tracked by a blockchain. Also, inventories and also the inventory chain can be tracked by a blockchain. Therefore, blockchain is the underlying technology that secures and verifies asset transactions. Bitcoin is a digital currency. So Bitcoin is open source. So therefore, the source code can be downloaded and run on any computer. There is, with Bitcoin, anonymous. So we see often with public blockchains anonymity. One of the big attractions of Bitcoin, because it is a public blockchain, in order to conduct transactions, we don't want everybody to know who is conducting the transaction. So therefore, only a wallet address is used. Therefore, securing blockchain and by anonymity. And it's also transparent. So all of blockchain, well, all of Bitcoin transactions are out in the open and can be viewed by anybody. Anybody can look over what the transaction was, and if anybody has any questions, they can look further into it. So Bitcoin was founded in 2009 by Satoshi Nakamoto. And that's actually a pseudonym, and nobody really knows the true identity of Satoshi Nakamoto. The Bitcoin's website is bitcoin.info. And Bitcoin, there are several what they call blockchain explorers for Bitcoin. You can take a quick look at one of them. We see here, just let me refresh this. Here is, we can see the current price of Bitcoin, and we can see here a transaction. If we navigate into a transaction, and we can see some information about this particular transaction. And here we can see the hash of the transaction, fees, and we can see here, this is the actual block. So if we come down here, we can actually see the transactions. So you can go out here and watch Bitcoin transactions. This is just one of many blockchain explorers. And you can see here in the transactions, they are quite anonymous. the transactors are only known by their what they call wallet addresses. But we can see how much Bitcoin was transacted. BTC is the abbreviation for Bitcoin, and you can see the date and the time that the transaction was confirmed. So this is currently the transactions that are in this most recent block. And again, Bitcoin is the largest cryptocurrency. And here's another website, bitcoin.org. And it's important to know that nobody owns Bitcoin. It is community based, it's maintained by the community, and anyone can join the community. Something comes up quite often, what gives Bitcoin their value? And that is a tricky question. You never physically take possession of a Bitcoin. It simply gets sent to your wallet. It's a digital entry in your Bitcoin wallet. However, though, what gives Bitcoins their value is the same thing that gives gold, silver, or even dollars their value. It's the demand for them. And gold, silver, diamonds are not liquid assets. They are assets, but they're certainly not liquid. They must be exchanged for cash in most cases to purchase goods or services. Uh, Bitcoin uh, was first discussed in a white paper that was issued by Satoshi Nakamoto in 2008. And this is an interesting white paper. It's called Bitcoin, a peer-to-peer electronic cash system. It is very interesting. It is surprisingly short. So we can actually take a look at the white paper. If we look here, we can go back to the beginning. And you can download it. You can simply go out and search for it. You can see they make the introductions, discuss some transactions, discuss one of the big problems early on with this kind of currency was the double spending. And you can even see how they begin to discuss how they will prevent double spending. And we can see here how hashes come in and timestamps, the proof of work, which we'll actually talk about, the network, and how space can be reclaimed. And again, the most interesting part of this white paper is how brief it is. It is only 8 pages. I guess 9 if you include the references. But the conclusion is right there on page 8. So I always found that interesting, that something that made such a big impact had its white paper that was so brief. And again, Bitcoin is the application that runs on top of the blockchain. So we see a lot of examples or a lot of analogies. We can see that we have applications like Google or Yahoo. Those are applications that actually run on the internet. We can see here's a reference to Instagram. Blockchain can be set up as a completely secure peer-to-peer, person-to-person transaction system for transacting digital cash or any items of value. So, and we see here transactions can be as simple as using a smartphone or any device, so an app. So the assets are exchanged electronically on an application. We always have to have something like that. And blockchains run in a truthless environment. So this allows for transactions to be completed without providing a third-party trust. Quite often, anytime two parties need to transact, a third party like a bank is needed to provide trust, to operate, to update the ledgers. Well, with Bitcoin transactions, we don't need that environment because the ledgers are updated automatically and you can see them updated instantaneously. So again, we see here how the vision for blockchains Blockchains will be running on the internet, just as today on the World Wide Web, the World Wide Web runs on the internet. So a lot of people don't know the World Wide Web is actually a section of the internet, and blockchains would also have their own section of the internet as well. And blockchain, with its mix of cryptology, so it secures transactions using cryptology, transparency. It also distribution. It results in a powerful new technology for security and immutability. So the way that the blockchain is constructed allows for distribution throughout the world. And just like we saw in the Blockchain Explorer, anybody can view the transactions. It's the number of users can go up and up because blockchain is built in a distributed type of architecture. So you can download the Bitcoin ledger, and then that would allow more users to participate. And it does decrease the costs of transactions because we transact directly on the blockchain, so we update the ledger ourselves. And this provides for less expensive transactions and paves the way for what we call micro transactions. Today, micro transactions, very, very small, maybe fractions of a dollar, even below 1 cent, really cannot be completed because of fees. And a lot of times the fees really just involve updating the ledger. So before blockchain, microtransactions were just too expensive. But today we actually see that we are able to use our applications for transacting in cryptocurrency. And in many ways, blockchain is already being called the technology of the decade. We'll all see. It is quite secure. It is a significant advancement, and we don't know if any of these statements, we don't know how true they will be, but their chances are we will be affected by blockchain in some way. And one of the key things about blockchain, which makes it very attractive, is it's creating new ways to solve old problems. So with the transferring money, before we just accepted that we needed a PayPal, we needed a bank to facilitate us in transferring money. Well, with a blockchain and a Bitcoin, we don't need that. We can update the ledgers directly. We can track data and files. So just like we track Bitcoin, we can substitute in there data like music, music files, or files like the deed to a house or the title to a car. Automatic contract execution. So blockchains can also be used to execute contracts. We know we can complete transactions on a blockchain, and the next step there would be executing the terms of a contract on a blockchain. And that's actually called a smart contract, which we'll talk about later. A few things about blockchain. It is decentralized and distributed. So a decentralized network in this case means there are full copies of the Bitcoin application on what we call nodes throughout the world, and they are absolutely identical. So you download the Bitcoin ledger, you download the application. Every peer, or every node, every computer is running the exact same software with the exact same data. The data is immutable and incorruptible. We'll talk about later how we actually why data is immutable on a blockchain and why it is incorruptible. Highly secure. Well, for these reasons alone here, the immutability and incorruptibility, that goes to high security. And the blockchain nodes contain replicated data. So since every node on the blockchain has the same data, if any node would go offline, we would have another node ready there to take its place. And data logged according to the community agreed algorithm. So the community actually makes the rules on how the blockchain will function. and it can be permissionless or what we call permissioned. So on a Bitcoin, everybody has the same access in Bitcoin. Everybody can view a transaction, everybody can execute a transaction. There are blockchains that run what we call permissioned models, where we actually have roles and we have permissions to execute transactions. And we'll talk about that later. And we can see here again a depiction here, a workflow of a transaction on a blockchain. One user wants to send money to another user. That transaction is broadcast on the network. People we call miners add the transaction to a block. The block is broadcast to every other party, and those in the network approve the transactions, and then the new block is eventually added to the blockchain, and the updated ledger moves that money from A's wallet to B's wallet. And so if we think about it in some way, what's one simple way that we can describe a blockchain? Well, it's been talked about that it's almost like a spreadsheet. So the whole ledger could be like a single spreadsheet. So imagine a spreadsheet distributed on computers throughout the world, the same spreadsheet, and on all of these computers, somebody is maintaining the spreadsheet, and they're updating the blocks with various transactions. So since everybody has the same copy of the spreadsheet, we'd have to say to ourselves, well, even though we are updating with the same general information, the spreadsheet copies could get out of sync. So they may differ slightly. So therefore, a consensus method is needed. And what happens with the consensus method is we all enter the transactions, and there is a consensus algorithm, which we'll talk about shortly, that allows somebody to be the first one to display the transactions to the whole network, and then the network can vote. And once that community votes, everybody resyncs or gets a fresh copy of that blockchain. So that's what we call the consensus method. Proof of work is the current consensus algorithm or consensus method of Bitcoin. It's very popular for blockchains. Proof of work started as a solution to prevent computers from sending junk mail. The idea was that computers that may potentially send mail would have to perform several calculations first before they could send anything. Well, you're only going to send something worthwhile when you have to perform these calculations ahead of time. So that was the idea, and so this proof of work had already existed, and then proof of work was identified as a excellent consensus solution for Bitcoin. Generally today, there are considered to be two generations of blockchain. Blockchain first generation would be a Bitcoin. Blockchain second generation is where we can actually write applications on the blockchain. So a first generation blockchain, well, let's just say that with Bitcoin, it only manages its native token or its native coin. It doesn't do anything else. So that's a good example of a first generation blockchain. Blockchain 2.0 provides tools that'll take action on the records that we keep. So not only can it generate actions such as the parties, certain conditions for the parties that have to be met before any kind of transactions can be completed. You can also transact any kind of asset, not just the blockchain's native token. So second generation blockchains provide us the method to manage any type of asset, a home, an automobile, the deed to a home, a birth certificate, possibly even a driver's license. And smart contracts are programs that actually run on the blockchain that take action on the records. We'll talk a lot more about smart contracts coming up. And so the distributed ledgers that run on the computer hosts, they're called nodes. So they are computers that are running the blockchain software and the blockchain ledger. So nodes in general contain a copy of the full blockchain. So that is true with Ethereum. That is true with Bitcoin. There are some exceptions to this when we start talking about private blockchains. And this distribution allows the blockchains to be always up and running. So blockchains are resilient. In blockchain, the distributed users are called miners. So you might hear the term miners or mining Bitcoin. They are maintainers of the network. So miners maintain the blockchain and keep it updated and keep it organized. Miners update pending transactions on their individual nodes. And miners compete to verify the transactions. So once verified, the transactions are then relayed to the rest of the nodes on the blockchain. So that data is sent out. That's that resynchronization that we just talked about. And miners are paid a reward when they are the ones that are voted on as adding the transactions. And when they're paid a reward, they're paid in the case of Bitcoin, the miners are paid Bitcoin. And for other blockchains, they're paid in that native token. And so this is how new cryptocurrencies are minted. And then once verified, these transactions become a permanent part of the blockchain. There are several good videos on blockchain. And these are just two of them right here. So please, if you can, take a look at these. Take a look back at your learning materials if it's easier to get it from your learning materials. And we can see here, so Bitcoin is considered the first blockchain. That's probably true, although there are some that would disagree with that. And we talked about this before, that nobody takes physical possession of Bitcoins. So Bitcoins are actually never even downloaded. They will remain, they actually are entries in a ledger that you can view through your Bitcoin wallet. And the ownership of the Bitcoins, just like we saw in the white paper, is tracked by the Bitcoin blockchain application. So again, if user X needs to pay user Y 2 Bitcoins, the Bitcoin blockchain is updated with the new ownership. And we go back to that white paper, you can see here, it's really the change in ownership that is tracked on the blockchain. So you could see here the ledger entry would be something like user X has now 2 fewer Bitcoins and user Y has 2 more Bitcoins. If we are using, this is we can see here one way of transacting, in this case, Bitcoin. So we can see here we can actually scan. You can see the address here. My wallet address is quite long and sometimes it's hard to copy. So these QR codes really help. And so the wallet itself does not actually contain any Bitcoin either. It contains your credentials to access the Bitcoin application. And the QR codes just simply make the transaction a lot faster and a lot simpler because everything can be done by an app. And you can see here the user's wallet address. This is called your public key. And everybody knows your public key, just like your address. If somebody wants to send you a letter, they need to know your address, and your address is public. In order to decrypt a transaction, you need what's called your private key, and your private key is hidden within your wallet. Your private key decrypts the transaction. So it's a two-key. It's what we call two-key encryption. And we can see here again the anonymity of a Bitcoin transaction. We can see here the addresses, the input address, the output address. We can see the amounts here. any fees, other information. Again, this comes from a blockchain explorer. And just something to think about in general, if you buy a candy bar from a store with cash, what ledgers are updated? Well, think about that. If you buy a candy store with a credit card, what ledgers are updated? What would be more expensive? So in my opinion, I'm thinking with the credit card, because we have that third party. The third party's working in the cash too, but we have that third party working immediately, making all those updates. And just for some work, or if you want to try something out, go to blockchain.com Explorer and look at some of the Bitcoin transactions under the Bitcoin logo. You can actually see these are actually blocks right here, and then you can navigate into the blocks and see the transactions. And again, we can see a transaction here. Again, we navigated in, and we can again see. Well, this says unconfirmed transaction. Interesting, but we can see the transactors here, and you can see their wallet addresses, and you can see some information about the transaction. So to summarize, we looked at the inspiration of Bitcoin, and we had our introduction to blockchain and some of our blockchain transactions. So here's our assessment. So please go into your learning materials and take a look at the assessment questions. And here are additional resources. So you can get more information from your learning materials as well. And if you're interested in more blockchain training, here are some additional courses that are offered. And in our next session, we are going to look at the impact of ledgers on society. Thank you.